since Monday at least, if not last week. How do we completely forget that we were having a test yesterday? All day Wednesday, what did we do?
Just reviewed.
We reviewed for the test, right? I gave you extra practice for it. We've got to remember a test is coming up. What did you do to prepare for yesterday's test? So I'm going to talk about a couple of these things, and some of y'all are going to block me out and not listen, but you need to. Guys, when studying the class before is not enough time to prepare for a test that we've been working on the concepts for 3 weeks, right?
Yeah.
You got to study your equations. That's a good detail. Recursive and explicit. Looking over a DYU is not enough. Just saying studied is not enough. I've actually told y'all this before, and please understand, I'm getting animated, I'm getting a little frustrated, because you are capable of amazing things, and some of the stuff we did is not going to help us be better. I never study unless I got to. Okay, that's fair enough for that person. I lied. Legitimately, there's some people that don't need to. But look at a proficiency scale to make sure I knew what everything was. That's good. Remember, I've told you on here what's going to be on your test, right? Those proficiency scales tell you that. Is it enough, though, to just look over your notes and just look over the practice problems?
No.
The answer is no. I talked about this. What do you need to do with that?
Practice questions.
You actually need to practice the questions. There was one question on that test yesterday that I did not feel 100% comfortable that everyone would know it, and it was that percentage question, which is why I was willing to give you a table so you could do the rest of those questions. Like, legitimately, okay? We had done everything else time and time and time again. And I know someone coming in and was like, you just expect us to remember and move on, but I don't. Like, there's no topic that we hadn't spent days on. The only thing that on the proficiency scale that we didn't spend days on was the X and Y intercepts, because we didn't. I didn't put it on the test for that reason. Every single thing we've done time and time again. Reviewed it time and time again. Like, we talked about arithmetic. Like, I need us to recap this. We talked about functions for a few days. We talked about arithmetic and geometric sequences essentially for 2 to 3 weeks. Talked about linear and exponential functions. Talked about constant additive rates of change for 2-3 weeks. We talked about constant multiplicative rates of change for 2 to 3 weeks. I might add in extra detail like domain and range, but then we're still continuing with linear and exponential. I might add in the detail of discrete versus continuous, but then we continue practicing with that. We've done everything that was on that test, time and time again. We've got to make sure that we are doing what we need to do to learn outside of class. Now, I do want to encourage, for those of y'all who are talking about why do we work in groups, and you're like, I don't know, I need you to hear what the students who understand why we work in groups are saying. To help each other communicate and understand things better as a group. I think there was one that I really liked in here, because it's more brains and it gives you different ideas. Hey, are there going to be times when you may not know what's going on?
Yes.
Yeah. There's one of me. When Mr. Anderson is here, there's 2 of us, but there's 20 of y'all. I can't teach individually each one of you every single time. But do you have a small group that you can ask questions of to talk through ideas and make sense of what's happening?
Yeah.
Yes. The whole point of having a small group is to talk with each other. And I know someone said, hey, I don't like talking with people, and I don't like talking to people I don't know, but here's the thing. In your life, Coriana, in your life, are you going to have situations where you have to meet new people and talk with them? Okay. So should we work on getting better at that? Yeah, like if you don't ever practice getting better at it, it's not going to help you. Malia, are you going to have times in your life when you meet people and have to work with people, maybe at your new job, whatever it is? Right. Rihanna, are you going to have times when you meet people in the workplace that you have to get to know them? Yeah? Victoria, you going to have to meet people in the workplace? You praying not? What do you plan on doing for your career at this point? Okay, I would highly suggest we start thinking about it. Dean, what do you plan on doing?
Construction.
Construction, you going to have to work with people in that construction field? Yeah, Parker, what about you?
Well,
Welding, are you going to have to talk with people in that situation? You're going to have to meet new people? Sometimes, guys, there's very few things in this world that you can get by without talking to other people. There's very few things in this world that you can get by without learning from somebody. So first things first, I know that we may not be comfortable talking in groups. Before I started teaching, absolutely hated talking in front of people. I still get nervous whenever I talk to a larger crowd than a classroom. But it's important to get better at the things that we struggle at. Not to say, oh, I don't like it, so I don't do it. Again, the other thing is, when I look around this room and I look at these groups, there is somebody in every group that I feel confident can figure out what's going on and talk about it with their group members. Every single group, there's someone there. Which means you need to engage each other's ideas. When you are lost, ask questions. On the test yesterday, I had someone tell me, Mr. Kinney, I just don't know how to graph.
That would be.
Okay, so Finney said, I was thinking of someone in fourth block, but Finney said, I don't know how to graph. Guys, we have been graphing as a part of this unit since the beginning, haven't we?
I know how to graph, I just didn't know how to graph that one.
Okay. But, oh yeah, I did their percentage one. It still doesn't change. But guys, have we been graphing since the beginning of this unit?
Yeah.
Yes.
Okay. So like if you were struggling with graphing, again this goes more for my fourth block, if you're struggling with graphing, can you ask your group members and get them to help you actually graph those points? Yeah. If you're still lost after talking with your group members, can you ask me? Yes. Can you ask Mr. Anderson? Guys, when you talk your ideas out and you ask questions, you're going to learn more. You have to take a level of personal responsibility within that group work though, and you have to make sure that you're engaging. Favorite part of class, a lot of us are talking about the group, obviously. There's some of us that don't love class, and I'm sorry for that, but I still think you're capable of amazing things. The group work has been shown to help students grow and learn, and so I'm going to continue doing that. A lot of us are saying the vertical surfaces, but work with each other. The group works will really help. And I will say, I know, this is interesting, I didn't expect to see this. What is your favorite part of class every day? I guess how we switch groups every day. I know for some of us that we don't love having to switch groups every day, but that means you get fresh ideas from new people every single day. That means that you have someone else that you can ask questions of, and it's randomized, so I'm not putting all the strong people together or making someone feel stronger or weaker. Yes, at this point, have we started to figure out who, have we started to figure out who may be naturally more gifted at the problems in the math?
Steve.
Okay, so
Emily.
there's quite a few of us, and like y'all are saying, Dean and Leah, and I would agree that they're really, really strong students, but there's plenty of others in here. John's a pretty strong student, right? Amaya always knows stuff if y'all can get her to talk, which is why I need us to talk more, right?
Yeah.
Like when I look around this room, we have a lot of really strong students, and if we could bring our ideas together better, and I'll say this, Brianna, when she started talking more this past unit, you started learning more, right? Guys, if you trust me, just like Caleb did 2 years ago, if you trust me and start to talk within your groups and focus on your learning, focus on your growth, you will learn more than you ever have before. And not just learn for a test, because I feel like that's what a lot of us want, is you want me to tell you exactly what to do, and then you practice it a bunch of times, and then you take a test.
Yes.
That's not real learning. That's why most of us, after that unit, completely forget every single thing that we learned, and we dump it out afterwards, because we learned it for a test, we didn't really think about it, we just programmatically did it. So, I promise you, I get it. Is my class very different than any other math class you've probably had?
Yes.
Probably, except for Malia, because she had me 2 years ago. Okay? It's very different than any other class. I get that. It is specifically and specially designed to give you the best learning situation possible. If you trust me and you do the things I ask you to do. But you do also need to do the practice outside of class. Yes, Finney?
Will you write the test?
No. Have I even looked at the test?
No.
No. Been working on other things I have to grade. Okay. Will I get them graded? Sure. Do I want to get them graded this weekend? Yes, but I got other things I got to do before that. All right, so Agenda, we're gonna learn about parent functions. Mr. Anderson, can you pass out the Freire model for the parent functions? They're in the back, yep. Okay, so does anyone remember, and so like if we finish parent functions, we're gonna move into the different transformations. And so I don't have a proficiency scale yet. I will have one for you on Monday. I've actually never taught this unit in Algebra 2 before, but Ms. Granberry and I talked about it, and we decided that this would be a good unit for all of our Algebra 2 students. It's going to be a short unit though. Our test will probably be Friday, next Friday, because there's so little involved in this unit, okay? Now, I'm going to teach you some things that you can make a choice to memorize all the rules, or you can learn some basic pieces that will always work. So the first thing I have to ask is this: what do you remember about what a parent function is?
It's the father and mother of the function.
Oh, that was genius. I loved it. But no, for real, like you did parent functions last year in Algebra 1. I can guarantee you, no matter who you had, you did parent functions. Anyone remember anything about parent functions? Nothing? You don't remember this?
Can you just write the equation? I probably know.
Yeah, I'm going to give you, well, technically all the equations. So let's look through the different parent functions that we're going to be looking at. We'll come back to it. So the very first parent function, and then we're going to come back to that first slide in a second. But the very first parent function, what does it say?
Linear.
Linear, okay? Anyone have an idea what a linear parent function might be?
It's linear.
Well, it is linear. So what would the equation be?
Y equals mx plus b.
So mx plus b is a linear function, but it is not the parent function. It's just y equals
X. X.
just y equals x. So you can go ahead and write that equation down under linear. Let's start to look at some of the other equations, see if we can find what the pattern is for the parent functions. All right, so the next one is quadratic. Anybody remember the equation, like the basic detail that makes a function quadratic?
No.
Nothing?
I don't even remember. I can't
This
So
is why I'm trying to teach differently.
X equals n minus 1.
Well, that was part of a recursive. Ignore that. I'm going to write this in a second, and I pray most of us just go, oh, quadratic. Oh,
I thought X squared was X reduced.
it's a good question. Does anyone remember what exponential would be?
Y equals mx. No, y equals m. No, y
Shouldn't it be
y equals.
squared?
First time I met the baby. Y equals x. No, y equals mx.
Oh my
No.
God.
Y equals 8. Wait. Y equals 8 times bx.
We're going to come back to this later. What's the difference between these two?
It's just X, but I'm going to sign
The b is it's an
What
x
we
bar.
like? The X is the exponent.
Remember, the x is the exponent, indicating that I'm constantly, repeatedly multiplying. In this case, how many times am I multiplying?
We don't know.
Only twice, right? With an exponential, we can multiply by b 1 time, 2 times, 3 times, 4 times, because that variable is changing, right? So remember, with that exponential, the variable is in the exponent. So hold on to that. So quadratic is y equals x squared, okay? So the parent quadratic function is y equals x squared. All right, the parent, the next one I think is cubic, right? Anybody have a guess?
Y equals x third. To the-
Y equals x to the third, or x cubed. Okay, that's a cubic parent function. Okay? No. Oh, you have exponential.
Wait, what
But
do
hold
y?
off, that is not the parent function.
What do we write? Y equals x squared. Exponential.
Say again?
Y equals x squared is exponential.
No. What was
Why is linear? Why is
No,
quadratic?
quadratic. Remember, y equals x squared, the exponent is a 2, not an x, right? So exponential is when the exponent is a variable. X squared is your quadratic. X cubed is a cubic. All right, what's the next one I have? A square root?
I wrote it down.
It's the little thing.
Isn't it square root X squared?
Not square root of x squared, just the
Y equals.
square root of x.
Okay, I wrote it.
I remember
Okay,
this.
so I'll go ahead and label these: linear, quadratic, cubic, square root.
Miss Mo, we did a long equation, and it was for everyone. We had to, for the square root, it was the whole equation was under the square root.
And there's an expression on the square root, that's what we're about to go into. But we gotta understand our parent functions first. What's the next one? Cube root. Anyone know what that equation would look like? So y equals,
I just wanna know
I don't know where it's
the radical. So the radical, not x cubed.
Wait.
Does anyone know where that, so it's not gonna be squared, because remember, it's a what type of root?
Square, cube.
It's a cube root, okay? Anyone know how we change that radical to make it a cube root?
Don't you put the real,
There's a 3, do you know where that 3 goes?
beside the radical?
So like, right here,
No, on the side,
On the
right.
other side,
No, that
You just saying outside of.
like right here.
yeah.
No, you put it in parentheses.
What?
Do you put on like on top of the egg? Like it's
Those good thoughts. Okay, how about this? One person per group, go grab calculators for the whole group. So one person per group, go grab calculators for the whole group. Should be 20 back there.
Hey, bro.
I lost everything I know. We could
Hey,
go,
bro.
go to TV Project. We need to go.
Here.
Appreciate it, right?
Somewhere.
Ooh, that way, hey. Deion sound great son.
No, cause that.
You always hang, bro. Oh, everybody. He said one per group. We need one per group. Per group.
No, one person grabs one calculator per person in the group.
Hey, we need one more.
You're right.
We're missing a calculator.
Let's saying X.
I'm right.
No, you're right.
If we're missing a
Wait,
calculator,
so everybody
stats
need a
would have
calculator?
it. Huh?
Everybody need a calculator?
Yes. Is there anyone who doesn't have a calculator?
But
Who doesn't have a calculator?
well, that's what he was trying to say before. Is it was all the way outside.
One's right here. Okay, I thought there was 20 back there. All right. So,
It might be.
hey, pause for me. I need y'all to look at the calculators. Okay? I need you to look at your calculator. So you actually have to pick it up. I need you to look at those buttons. Chelsea, go grab the calculator. It's on your desk.
I have a calculator.
So you need a calculator page. Here's what I need you to do. Does everybody see where there's an x squared?
Yeah.
Okay,
Yeah.
what's above that x squared in gray?
Two.
No.
Trig, whatever that is.
Trigonometry.
No. Y'all stop pressing buttons. Listen.
You,
What is in gray above the
control.
square? The square root. The control button is there, but I'm talking about
Oh,
not a button.
okay.
There's a little gray thing above that square. What does it say?
oh, I see it.
You see that square root? Okay. To the left of that square
I'll figure it out.
is a little caret symbol. To the left. What's that?
It's
caret
n
symbol
square
mean?
root of x.
Okay, so caret means any exponent, but then in gray above that power is a what?
N square root of x.
So and it looks like this, right?
Yep. Yes.
So when it's a square
Not
root,
really, but yo.
okay, when it's a square root, there's actually a number here that we don't have to write. Do you know what the number is that we don't have to write for
Yeah.
square root? 3.
How's
Remember, it's a square root, kind of like a square, so it's a what? It's a 2. But we don't have to write the 2 because it's used so often. So how are we going to rewrite this? What's going to go right here? The 3. That's the cube root of x. Notice it's not in front of the radical, it's really right inside of that little crook of the radical. So where it has that angle, that's where the 3 goes, inside where that n is. Say again.
What makes it different?
We're going to talk more about it, but so just for now, trust me on y equals cube root of x. We're going to talk about this equation later. Okay? I would hope so. Okay? Starting to come back. But these are things legitimately, this is what I need y'all to understand. Like, we have to learn these things well enough that we don't have to be reminded, we need to know them. Like, and I know I didn't get all of us to that point on the last test, and I hate that. But also, we've got to actually remember across the board from one year to the next. We've got to get to that point. We got to hold ourselves accountable to that. Okay, the next one says exponential, right? Okay? Now, this is the exponential equation that we've been working with. But the thing is, that's not the only exponential equation out there. And also, there is more going on in this equation than what the parent function will have. Look at everything that's going on with all of these. Do we have a lot going on with those equations?
Yes.
No.
Look at each equation, not all of them together. Is there a whole lot going on here?
No.
Or here? Or here? Or here?
Yes. On cube root.
Do I have things going on, or is it just the cube root? Just the cube root. So when I talk about my exponential, I don't want a whole lot going on. So what is the equation going to be? What is it? B raised to the x. Now, b raised to the x is not the most useful. One of the most common exponential equations is 2 to the x. So we're going to use y equals 2 to the x as my exponential equation, my exponential parent function. Okay?
Absolute.
And then absolute value. So what is an absolute value function? What is that equation going to be?
Y equals the little line.
The little lines, absolute value of
X.
x, right? That's the absolute value equation. Please remember, these are only the equations. Are equations the only ways to represent our functions, though? No, right? We need to remember what we're about to learn about these parent functions is not just the equations. You got to know the equations. But we also need to know how to get the tables and how to get the graphs. And you can memorize all the tables and graphs, but how many functions is that? That's 7. Do you want to memorize 7 graphs and 7 tables? So we need to learn how to use those equations to create our own graphs and tables. And that's how I have constructed this task. Now I'm going to go back here. So what is a parent function? Remember, a lot of us were thinking like right here, y equals mx plus b, right? And right here we were thinking a times bx, which those are linear and exponential, but those aren't the parent functions. What's the difference? What is a parent function then?
It's the parent of all of those.
I mean, no, because we had this is a parent function, this is a parent function, this is a parent function, this is a parent. Any ideas at this point?
Y equals.
Hopefully we do. Okay, let me contrast this. So these are all parent functions right here. Here are some that are not parent functions. Mr. Anderson, give me one that's not a parent function.
X squared plus 5.
Okay, not a parent function.
Y.
Can you give me one more?
4x.
Okay. I'm going to come up with one. Let's do 2 square root x minus 3. All right, Mr. Anderson, last one, and then we're going to have them think about it.
3 times 2 to the x plus 5.
Down here or up here?
Down on the bottom.
Okay. Just take a second, talk with, and I say a second, 60 seconds, actually talk with your group, because remember, when you think about things and you talk about things, ideas are started generating. Why do you think these are all parent functions, but these are not? What's the difference? Talk with each other, we'll come back in 1 minute. Talk to your group first. I need you actually talking.
Mr. Kennedy.
You can use function notation with parent functions. You can use function notation with parent functions.
One simple problem, you know, it's not too much going on.
What are we thinking? Okay, have you talked at all?
No, not yet.
That might help you start thinking about some things.
Well, the parent functions could have f of x too.
I don't know who's on the whole unit. It looked like the old unit. He compared it with the new unit.
Because f of x
So it
is
is
the
an
same as y.
expression, like it's an equation.
But the other side is also
Everybody's-
written as y. That doesn't necessarily make it a
Like
parent
that
function.
is a full equation, there may not be as much going on. Okay.
Wait, what did y'all have?
4x squared.
Two numbers.
Exponential.
Mr. Johnson.
Yeah. So we might go in and update those to include f of x throughout. You can use function.
It's just getting called.
All right. Oops, it's been a little over a minute, so let's talk about this a little bit. So first off, I do want to go ahead and tell you this. I probably should have thought about this earlier. Don't forget y stands for what? That is the what for that
That's the
function.
intercept. Slope.
That's the
Input.
output.
That's the output. Remember, y is our output. What is f of x, g of x, h of x, k of x, j of x? What are all those? Those are also outputs, okay? So we're going to change everything, I think, over to function notation to help, but these are all outputs, so whether we use function notation or not, that doesn't change anything. I heard a group over here saying, well, these are not full equations, which I get what we're thinking, and I want to put better language with that. They're full equations. They have an equal sign, they have an input, they have an output. So what are they thinking? I heard some good things over here from the Kings. What were y'all talking about?
So why?
I thought y'all talked about something else. I know you talked about something else.
Yeah, like how the problems are.
But what about the problems?
I know.
I forgot what he said.
Oh my gosh, guys, we're gonna remember what we say from 1 minute to the next, and you'll literally talk for 60 seconds. Okay, Dalton, what did you, Victoria, and Dean talk about?
We mentioned how it's possible that there are no surplus per line.
Ah, so the parent functions are in the simplest form. Okay, so that might be a start to the puzzle. Any other ideas that we built on or talked about in our groups? Aces, did y'all talk about anything?
Yeah.
What'd y'all talk about?
I just really talked about the cube root and stuff, how it looks a little complicated, but I'm gonna get used to it.
Okay. Fours, what did y'all come up with?
We didn't.
Nothing? What'd y'all come up with, Abby? Did y'all talk about anything at all? Nothing at all.
We talked, but it's not right.
What'd you talk about then?
I don't know.
Okay, here, guys, I need y'all to understand, not right and right are perspectives that aren't necessarily the best. Like, is it something we can learn from or not? And I think it's something we can learn from.
The k of x is exponential. Is exponential.
Okay? So is k of x exponential?
It's 4x squared.
Okay, do y'all agree that it would be an exponential function then?
Yeah.
Everybody agrees? I say Malia's shaking her head no. I'd be surprised if everyone agreed that 4x squared is exponential. What makes exponential exponential?
Exponent is constant factor.
So it's got a constant factor, but what about the exponent? The exponent is a variable. Is that exponent a variable? Which of these functions is an exponential function?
Oh, f of x.
F of x. F of x.
No.
J of x would be an exponential. Right? That variable in the exponent. Notice it may be more complicated than we've seen before, but what is making, let's keep pushing on this idea. We said parent functions are in the simplest form. What does that mean? What do we have here that we don't have here?
Why? That's awesome.
We have a
I've already addressed that. How is that all that you see that's different?
The numbers.
Well, thank you. Guys, do we have addition anywhere over here? No? Do we have multiplication by 4 anywhere over here?
So it has to be that.
So it has to be this to be a parent function. If it is something beyond this, it's not a parent function, we would call it a transformed function. We're going to talk more about this. Notice the whole thing is about, if you look at the very top of the thing, it talks about Unit 3, parent functions and transformations. Okay, so parent functions are in the simplest form. So what do we mean by that? There are not, or there is not, I should say, there is not what?
Did we write all of this under?
What a parent function is.
Do you
Okay.
want us to write the equation or not?
You can, but let's get these notes down, and then if you have time, if you have space, write it down in a second. But parent functions in the simplest form, there is not what?
Numbers.
There is not multiplication or addition. Right? As soon as we add in, and when we say multiplication, don't forget that means division as well, right? When we say addition, that also includes what? Subtraction, right? As soon as we add in this multiplication or addition, that's no longer a parent function. So what defines the parent function is the main operation. What I mean by that is here, when we say y equals x squared, what is defining this quadratic?
Equals.
Nope, not the equals. What about that exponent? Be careful, it is multiplying x by itself, but like, what would you call this exponent? It's a square, right? Like, what makes this quadratic? The fact that it is squared. What makes this cubic?
It's cubed.
It's cubed, it's power of 3. What makes this a square root? The radical, not just the radical though, because you have lots of different types of radicals. Which radical? The square root. What makes this a cube root function? Better be a cube root this time, right? What made this exponential? So the exponent is a variable. What made this an absolute value? The absolute value symbol, right? That operation. So what defines the parent function is the main operation and no something, okay? There's a main operation and that's it. And I've already said this word once. We're going to explore this word more, but what are we talking about in this unit? Parent functions and what else? I mean, there's always going to be variables, but it might start with a T. Transformations. And no transformations. As soon as you have one transformation, it is no longer a parent function. You remember how we talked about multiplication and addition? You know what those are going to create? Transformations. We need to explore them more, but we need to understand our parent functions first. So listen, parent functions are in the simplest form. There's no multiplication or addition. What defines the parent function is that main operation and no transformations whatsoever. The one thing I will point out is linear is maybe the hardest to see. Does anyone know what the main operation is in a linear that makes it linear?
The one?
X.
One what? What's one?
The exponent.
The exponent is one. Great, yeah. Notice a linear is y equals x raised to the first. It's an understood power of 1. What makes a quadratic is the square, cubic is a cube, etc. So, if you want to take a second to write down those parent functions in that region, you need to make sure you have those notes. You've got to understand what a parent function is before we continue this unit. If you want to write down a couple examples of what's not a parent function, that would not be a bad idea as well. But I will point out, parent functions, you're going to have a different quadrant for each of those, so you don't necessarily need to write them all down, but maybe a couple of examples to refer back to later would be a fantastic idea. Let me know, I've memorized that button. Press.
5 is settings, and then 1 is language. Yeah. I'll remember that for sure. That's funny.
Yeah, I think you have to hit doc first, right?
Yeah, you gotta be on the home page. Or, well. Oh, really?
Yeah.
You could just.
So if you're here, doc 7.
Oh, so
That's
if
what
you're
I'm
on a
saying.
doc 7?
Yeah.
Okay, because I was on the home menu and then it's 5 is
Yeah.
something.
Yes, yeah, doc 7. I've done it enough. Yep. Yes, ma'am. Oh, I thought you said it's okay. My bad. Okay, is there any questions? Like, it looks like most of us are done taking notes. Are there any questions I can answer before we continue? No. We good? Okay. Some of these parent functions, hopefully you remember what they look like roughly, but I want us to become more precise with our understanding of what they are. And so we're going to look through this a little bit. So here's what we're going to do at this point. We're actually going to work within our small groups to develop each of these functions on vertical surfaces. That's why you have the white books up. Because I want you to, anybody have a guess what mathematical representations I want you to create?
Pictorial graphs.
Graphs and tables. So pictorial are good, but graphs and tables are going to give us the best look here. Now, here's what I want to do. I want to give you just one hint. I don't particularly want to start with a linear function. I'm going to start with a quadratic function. And what I will say is, I know I wrote y equals earlier, but there is that function notation. So what might be the best way to write the quadratic if we're talking about function notation? F of x equals
X squared.
x squared. Okay, so there's my quadratic. Now, hopefully again we remember roughly what it looks like, but we may not remember all the points for this function. If you don't remember exactly how to graph a function, what is every function, what is every relation comprised of? It's two things.
Equation.
Output,
Say again.
input and output.
An input and output. Could you maybe plug some values into that equation and figure out what the outputs are? Okay? That's what I want you to work on within your groups. I'm going to try to gauge how well we understand it. Okay? The one word of caution I will give is this. I do not just want positive inputs, I also want some negative inputs. You do too. You do not get a full picture of these parent functions without negative and positive inputs. Does that make sense? I'm going to go with a yes. I pray that makes sense. So, let's start with our quadratic. We'll bring it together. We'll talk through it after y'all have a few minutes to work on it. So remember, skip linear. We'll go back to it. Quadratic. Let's get it going. So let's get up. Let's make a quadratic
Can we pick any numbers?
table and graph. You can pick any numbers. Think about what might be the most strategic, though. What would be maybe the most efficient? So, two things that I want to point out. I was wondering if this would happen. So, one thing that I wasn't really expecting to see was us struggling to recognize these are literally which values?
X.
The x values. So what are these numbers right here?
Input.
Yes, but also inputs, right? Guys, whatever x values you put right here, these are quite literally your inputs.
Yes.
So all I'm going to do is when I have f of x equals x squared, okay, x is what right here?
0.
0. So if my input's 0, the output is?
0.
You need to hold on to this because we're about to do this with a whole bunch more functions. F of 1, 1 squared is equal to?
I'm at
1, right? So 1 maps to 1. 2 squared is?
4.
4. Guys, notice like just using the function notation 1, do it for most of your points. I know that like back here, you can do just the table by thinking through the operation, but I promise you if you take the time to practice using the function notation several times, and not one person doing the function notation every time, but everybody get a turn at practicing the function notation, it will help you master these ideas. And some of y'all again still ignore me and then be pissed when we don't know what to do on the test. Or you just listen to Mr. Kinney, take the time to do the function notation and it'll help. Now, two things at this point. First, I need you to be careful with your negatives. This -3 is inside of parentheses, isn't it?
Yes.
Okay? So this x squared, the x needs to be inside of parentheses. It doesn't matter as much with the positives. However, when I square a -3, that is literally saying -3 times -3. And what's a negative times a negative? Positive. You've got to be careful when you square things, okay? Because it is going to be a +9 as most of us eventually got to. And then some of us are going to be like, but Mr. Kinney, that's not what the calculator told me. Because what did y'all actually put into the calculator?
-3 squared.
Instead of putting parentheses.
Right. This, the calculator actually correctly understands. You typed in incorrectly for here, but what happens first? Multiplication or a power? Multiplication or an exponent? An exponent. The calculator actually understands correctly that this is the opposite of 3 times 3. You're only squaring the 3. That's why you got a -9. Nah, we got to square the -3. Okay? Last thing is, you're going to need to write down this table, make sure you explain where this table is coming from, and then the graph, don't forget, just take these points, 0, 0, 1, 1, 2, 4. Again, if you're one of the ones who say, Mr. Kenny, I'm struggling with creating a graph. 1, talk with your group first. If you're uncomfortable, talk with your group first. Then ask me or Mr. Anderson, because you're juniors in high school. We got to know how to graph points. And so you need to be personally responsible to make sure you ask for help in doing this. But, and I saw some of us already make this note, what is the name of the shape of this graph?
Parabola.
That is a parabola. The parabola is the shape of a quadratic. Okay? Parabolas just have or quadratics have a special name called a, quadratics have a special name called a parabola. Okay, please grab a seat, write down the notes you need to for y equals x squared. We need to try to get through all these parent functions, so we need to be quick, we need to be efficient, ask the questions you need to ask.
Oh, you didn't make the emotions.
Alright, so I want to talk through a couple of things with y'all, and I'm going to look at a couple of different graphs. By the way, hopefully we have started to get a feel for how this works. Walter, Malia, y'all gonna have time to work ahead in a second. Just wait a second. You're literally typing stuff into a calculator. Malia, just wait. Okay, couple of words of caution. So again, I need us to take the time. I'm not saying this for kicks and giggles. I'm looking around the room and seeing most of us not doing this. Take the time to practice doing inputs in and getting an output out. Because here's the thing. I would pray that every single one of you can easily cube a 1 in your head. It's 1 times 1 times 1.
Yes.
I pray that all of us can do -2 cubed, because it's -2 times -2 times -2. But you're going to get to functions that are not that easy. So when I say, hey, please do this thing, it's not because of just what we're studying right now. I know what we're going to go to in the future. So if I'm telling you this is a good idea for your future, trust me and do the dang thing. Practice inputs and outputs. So just take a second to write that out. That took me 10 seconds max. That doesn't waste my time too much, and it helps. Now, please notice when we cubed these negatives, did we go back to getting positives like we did with x squared, or did we get negatives again? So why did we get positives last time and negatives this time?
Because it's negative times a negative, which makes a positive.
We need
Positives times a negative.
We need to recognize how many negatives are we multiplying? 3. And a negative times a negative is times another negative is negative. Please don't put your foot on the wall where I have stuff taped up. Come on, I need that later.
Come on.
So, hey, excuse me. Hey,
Everyone makes mistakes.
hey, right here. So what I need us to do is I need us to practice substituting inputs in, getting outputs out, and that'll also help here. Now, word of caution again, because I see it back there, I see it over here, I saw it with another group earlier. I get that it's tough, but is this a function right now?
No. Because the vertical line is going.
Because that vertical line, right? I have one input mapping to at least more than one output. Okay? Next thing, and I see it over at this group as well. Hey guys, we're trying to get to 27, right? So when you look at your y-axis, can you go by ones?
No. Yeah.
I mean, you can, but not to get, I guess that's the 8, isn't it? Just kidding. I lied. I was thinking y'all were doing this 20. Y'all just ignore this 27?
Stop at 8.
Okay, perfect. Is it okay if you just stop at the 8? Yes, okay. My bad, I misread that. So, that's fine. Just make sure we're practicing this. Be careful again, because it was fine down here, but I would rather us have a kind of wonky graph than to not even have a function. Right? So notice now I've made sure that it goes at an angle through there.
So it just gotta be straight, like, I just like.
It doesn't have to
No, it can't be straight up. It cannot be vertical at any point.
You look,
Because
you
if
doing
it,
the same thing, what you doing?
come over here, get closer. This is also why I asked you to get closer, because it's not straight. It is not vertical.
Be closer.
That's what I'm saying. I am making sure, you see this red right here is vertical? You see how over here I'm to the left of the red, getting closer, 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 and then on the right side I'm getting further away from it? It's not ever vertical because it's a function, it's going out. Remember, right here we even have it, well, 3 would map to 27. So I got to get really vertical, but it's never going to be straight vertical. 4 goes to 64. So we cannot ever have it be vertically straight up. Okay, please take a second to write down your graph and your table and use your function notation to show a few inputs in and a few outputs out. The 8, by the way, did a phenomenal job of inputs in and outputs out.
I'm weak.
He's got a couple minutes though to get this down. Jaw, have you written this down yet?
Just sit down.
My fault, Victoria. I won't tell you.
Y'all want to forever.
I know it's
Like,
cute, by the way.
like a little scared nigga, some little nervous. He said, I'm for real.
You
Nigga about to drop his grade.
Walter, she's trying to give you props for real. Oh my gosh.
What?
Hey, really quickly, I do want to point out one final detail that I should have mentioned earlier. Has anyone noticed what is in the middle of our table and in the middle of each of these graphs?
Zero.
Okay. This is the origin. Nice, I love that language, right? The origin is a great place to start for what a group of functions called the polynomials, okay? We're going to explore those more later. But the origin, or at least an input of 0,
Can't wait for an announcement.
0 is a great starting place. So,
Nigga, bag it up.
it's one of those things I'm still trying to teach. So,
What's the word, that key word? It's called polynomials.
polynomials, yeah.
I heard that before.
Yeah, should have in Algebra 1. Hey, Jaden, we're still not done. We got 8 minutes of class, bro. So I don't know why you put a calculator up.
I'm already on.
Origin, okay? So again, input of 0, and notice at this point at least we're doing a couple of negatives and a couple of positives. But that 0 is a great starting input. 0 is a great starting input. Once you are done with these notes, you may go to your vertical surfaces, and I want you to start working on your square root of x. We need to get this going quicker, because I want to talk about 2 things with square root of x before the end of class.
When you fall once, why give over?
People miss the idea of what a square root actually is, and this is important. Please remember, what was 0 squared? 0. What was 1 squared?
1.
And 2 squared? 4. So when I take the square root of 0, what I'm asking is, what was squared to get 0? What was squared to get 0? 0.
0.
What was squared to get 1? 1. Now some of us tried to do 2 here.
Is that the announcement? Yeah.
Probably
can't hear.
They
If it's
okay.
down, like,
Yeah, did they turn it down in all of the classes?
Yeah, I think it's hard.
Alright, I'll talk to administration. Hey, when y'all try to do square root of 2, what did it give you?
See, that's why we be missing.
Let me see.
That's everything
The
important.
decimal is like
I don't even know what
1.414.
3, that was
Okay,
Are you going to put it?
so 3, it also gave us a decimal. But what is the square root of 4? What was squared to get 4? 2. Hey guys, I need y'all to notice this. What's happening to go from the squared to the square root? No, look at those points. What's happening? Okay? Square root of 9. What's square root of 9?
3. Is it by itself?
Not
Like, you
quite.
multiply by 3.
Look at these inputs and outputs. Guys, you're missing this.
I'm listening.
2, 4 became 4, 2. 3, 9.